Hi, how are you? Well, I hope you're having a good day. Welcome back to Fantastic Chemistry Podcast. Tuski and I are the host of this podcast, and we are proud to present chapter 13, Acids and Bases. Yay! Woo! Oh yeah! We are on chapter 13, so we have chapter 13, 14, 15. Here we go. That's it. All right. 3 more chapters. Heck in there, guys. In this chapter, you're going to see quite a lot of color changes. And so because we have a chemical compound called an indicator. And it tells you like the pH and acid base. We can talk about it. So our sponsor also have a lot of colors. So our sponsor for this podcast, KoolAid. Do you guys grow up drinking it? Do you guys like it? Most people do, right? So most of us love KoolAid, and we grew up with it, right? As like it's cool, or maybe like as a baby. I don't know if you guys are baby and you drink KoolAid. I had KoolAid very long time ago, and we still love it. Okay, never mind. So a little bit about KoolAid. So KoolAid is an American brand of flavored drink. Right, so it's a drink mix owned by Kraft and Heinz. You might have heard the like a cheese, no, what's it called? Brand named Kraft, maybe, right? Oh, but at least Heinz ketchup. You have heard about it. We will talk about this, the Kraft and Heinz, maybe a little bit more on the next chapter. It's really interesting. I forgot. the company, the headquarters of KoolAid is in Chicago, Illinois. Okay, and but go back in time. So KoolAid was created by Edwin Perkins, so this guy right here, in 1927. So somewhere between World War One and World War Two, as a liquid concentrate called fruit smack. So it look like that, fruit smack. Okay, at that time they sell fruit smack and other stuff as well. So by either by mail or door to door. This is like more long back then, 1927. That's like almost 100 years ago. It turned out that fruit smack was a hit. So later, Perkins, in his mom's kitchen, come up with a new way to sell fruit smack, but without liquid in it. So he found a way to remove the liquid from fruit smack, leaving only the powder, and that's how we got KoolAid. Okay, and that's how they spell KoolAid at the time. Cool and aid. It's cool. Is I don't know what aid means. So, and right now we have AID. At those times, ADE. Okay, and removing liquid from a concentrated solution is easy now, but back in the day, like almost 100 years ago, it's really difficult. Not to mention doing so in the industrial level, like a massive amount. All right, and we did that and sell KoolAid with 5 cents, and it was a hit. Yeah, people love it, kids love it, parents love it, grandparents love it, everyone loves it. So, and it's what a hit that KoolAid went on to many commercials, and many of them shows that they are so popular that they used like a jar of red KoolAid break through walls, and there are many of them. You can look on YouTube. It's quite fun to look at, to watch. And Family Guy, which is a famous TV show, make fun about it. So this is in 1999, the first season of Family Guy. Oh no, oh yeah. Okay, all right, that's a little bit about KoolAid, so let's take quite a long time to explain. Anyway, so acid and bases, so let's talk about it real quick. So review. You have seen acid before, right? So the acid, so strong acid are those in group 7. And we also have strong acid like nitric acid, sulfuric acid. These are strong acid. Okay. The rest we have phosphoric acid, carbonic acid, which is an acid in a soft drink, right? In a pop soda, or acetic acid, that's in vinegar. Okay. So you're gonna see a lot of hydrogen bond to a highly electronegative atom like in group 7 or oxygen. All these down here are oxy acid. All hydrogen bond to oxygen, and the oxygen bond to the central atom, carbon, nitrogen, sulfur, phosphorus. Okay, all right. And group 2, the hydroxide of group 2, those are strong bases, right? So if you remember the what do we call group 1, by the way? What's the name of the group 1? Alkaline. metal, right? Put in water, react violently with water, but water become basic, right? Alkali earth metals, that's group 2, so magnesium, calcium, hydroxide of group 2 are also strong acid. Okay. All right, review. So acids are compounds that produce proton ions in water. So Ha dissolved in water, you get proton and then corresponding base. Okay. Base on the other hand, so compound that produce hydroxide ion. All right, a little bit about proton. So this for our communication. So when I mention this, you know what I mean. Proton or hydronium ion are representation of an acid. Now take a look. So hydrochloric acid in water, so break up into proton and chloride. Proton itself is not really stable. So like an atom with a charge, not stable. So proton that exists in water, usually in a form where water molecules stabilize it using the oxygen atoms, right? Because proton is positive, oxygen atom is partial negative, so stabilize proton. I'm glad that, all right? But again, so right like this, proton is not really stable. Many times, people represent acid as hydronium ion, right? Look at the difference. So instead of just hydrochloric acid dissociate to proton and chloride. So hydrochloric acid react with water, and water come grab that proton, become hydronium ion. So look something like this. Same thing, right? Proton and hydronium ion are the same thing, okay? So, but you can show it anyway, but it's more popular with the hydronium ion, basically. Okay, so hydronium ion look like that. All right. Now, hydroxide, so as a representation of a base, so sodium hydroxide dissolved in water, you get sodium ion, hydroxide ion, right? Magnesium hydroxide, so 2 moles of hydroxide ion. Okay. All right, let's practice real quick. So complete the following equation of an acid dissolved in water. All right, so we have perchloric acid dissolved in water, right? So perchloric acid will donate a proton to water. So water will become hydronium ion, and perchloric loses proton, become perchlorate. That's it. Okay. All right. Can you do the second one? So calcium hydroxide in water. Well, calcium hydroxide is a solid put in water, so dissociate into calcium ion and 2 moles of hydroxide ion. Okay. Some of you said, oh, what about water? We dissolve in water. Do we have to put water just like in acid? You can put water in there, but water doesn't really do reaction with calcium hydroxide. Water stay here and also show up here, so you can cancel out. Doesn't matter. Same thing. Doesn't matter. Okay. All right. Let's go to more in-depth definition of acid and bases on the next video. Okay.